Hello, it's John again, and welcome to tutorial 37, the community game development series, where we're trying to develop a new version of Hunchback, and this is episode 22. Now, in the previous episode, we added some of our enemies to the game. So we added rocks, boulders, or rocks, whatever you want to call them, fireballs, axes, and we had a ninja working his way up the tree, up the turret, or better word. Oh, I don't know. I don't know. So, tower, there we go, that could be it. So, in this episode, we're going to try and implement some sort of leveling information system that tells the game how these enemies are going to behave, and and telling it sort of things like speed, size, duration, frequency, and a few other bits and pieces. Now, I'm not going to lie, I have done most of this, because it's taken a lot of time to get it right, and I didn't want to do it on video and take 6 hours. Yeah. So let's see where I am, because it's been a while since I've been in here. So let's open the project up. So I'm on my Raspberry Pi here, and I'm in by VNC. So it's remembered. Now it looks like something's installing. New Python extension. We'll let it install before we do anything. Hopefully it won't take that long. Come on, can't be that bad. Right. So what we're going to do is we're going to have a file with all the information is, and because we're using modern technology, we're not going to do a simple thing like a text file. Oh no. Oh, I forgot to put the keyboard thing on. There we go. We are going to use modern day data storage technology. Yeah. So, reloads required. Okay, here we go. So what we're going to do is we're going to store all the leveling information in what is known as a JSON file, which is a JavaScript object notation file. Now, you guys don't really need to know the ins and outs of JSON, yeah? Because we're only using this so we can store information about the levels. If you want to know about JSON, there's plenty of videos out there, but it's a quick and easy way of storing data in a structured way. Now, like I say, I've already done this already, so I'm going to cheat, and I'm going to copy from here to here. So we're going to create a new file, and we're going to call it, what have I called it? Levels.json. There we go. And then I'm going to paste it in. Boink. There we go. JSON. So basically, this is saying, right, I've got a collection of levels. Make it a bit more, a list of levels. Yeah. So this is level 1, which is going to use map 1, and then in that level we're going to list the enemies. And so I'm going to have a list of rocks, which is currently only 1 in it. Yeah. This is level 2. As you can see, it says level 02. It's going to use map 1, and the list of enemies is I am going to have a list of rocks, which is going to have 1 in, and a list of fireballs, which has 1 in. level 3 is map 03, but we'll change that to 01 for the moment. And it's going to have a list of rocks, and there's 3 rocks going to be thrown at us, a list of fireballs, which there's going to be 2, and a list of axes, which is going to be 2. And that's basically the construct of it. Yeah, you don't have to worry too much about Json. Yeah, and the information we're storing about the enemies is how high they are, how many seconds do we delay before we start them, what's the frequency in seconds, so once we've released one, how long do we wait before we release another one, and in this particular case it's 10 seconds. Direction, are we going left or right? Speed, well, bigger the number the faster it goes. The size, you know, because I think with rocks we have different sizes, so there we go. And in this particular case, set, rocks don't have sets, but fireballs do. They have 0, 1, 2 and 3, so that's what we use set for. And set for axe is it blue axe or a red axe, but all the rest of the information is the same, you know, what the height is and all that jazz. And that is basically all the information we're going to store to for this game. And like I say, it's in Json, because Jason's a quick way of storing data in a structured way. And so it's the way I've laid it out there, it's a bit more easier to understand, because we have a list of levels, and in those levels we have a list of enemies, and in that list of enemies we have a list of rocks or fireballs or axes, or we have a list of rocks and fireballs and axes, or combination of the 3. And that's what we're going to use. Now, to act on this, we need to change quite a lot of stuff. So let me get rid of that on here. And so the first thing we need to do is we need a way to read this in and then store it. So if my memory serves me correct, I read it in the game class. Let's have a look. Yes, I read it in the games class. So in here, so I've got new, so we're loading the chapter in, yeah, which is the game level. So what we need to do here is we need to create another variable called self dot all enemies, and we want it to be a list. And I'm falling back into bad habits again. And then what we're going to do, we're going to read that JSON file in. So let me go to where it is. Let's load map. Oh, yes, I created a new class. Okay, add levels.py. I think that's what I called it, yeah. So let's copy this. We'll paste it in there. So basically what this is doing is we're setting up a list of enemies, we're clearing it to make sure there's nothing in it, and we are clearing the level map, and we're setting the chapter, which is the chapter that we're passing in, yeah. And so what we do is we, I need to do the enemies class. So what we do is we load the JSON in to levels, and then in each for every level in the levels we're going to run through it. So we're going to say, is the level equal to the chapter? Yes, it is. Right, so we're going to create the level map, which is the map of the level we're going to be using, and then we're going to load the enemies from the list of enemies, and then we're going to run through them and create an entity inside the enemies to say what these guys are going to do. This is basically loading a text file. So we're loading the JSON as a text file. And that's what it does. It creates a list of all those things that we saw in the JSON file, but in an array for, or in a table for us to use. Now there's another file we need to create called enemies. E-N-E-M-I-S pi. And this is basically, if I can find it, there it is. This is basically taking the information from that JSON file, so what the type is, what the delay in seconds, what's the frequency in seconds, what's the height, direction, speed, size and set. And it's creating an item with all that information is that we are going to let run through when it does the update. So when it does the update, it's going to keep its own frame counter going. If it equals the frames per second, it resets. Then we're going to add a second counter, and that basically allows us then to do seconds remaining, and basically that's a timer counting down, not counting up. And then if it crosses the frequency, then we say another sprite is required. Right, so that we've got that done. In game, we can start implementing all this. So let me get back to game. So in game, we've got our list, we've got our enemy list. So basically here, we're creating a new, so this is no longer going to be called new. This is going to be called next chapter. And then we're going to recreate the new. We'll just put passing in there first. And what the next chapter does is it's going to do everything that we need to make things work. Yeah. So it's doing all the group clearing out and basically resetting the game. So what we need to do is, there's a few more things that we've got to do here. So walls, artifacts, enemies. Right, so we need now a collection of rocks, fireballs and axes. So we need to put that in there. That's it. And these are going to be our rock sprites and fireball sprites and stuff like that. And I'll explain in a minute why we need to do it. And then we need to load our leveling information, which is here. And we do that before we do the tile generation. So we're loading the JSON file. We're leveling up with the we're leveling it with the current things. We're loading back the enemies into ours and the map data. So we need to import levels. Now, when I was messing around with this, I had a problem with the sprites. And what was happening is, when I created a new sprite, when the enemy's object was saying, "You need a new sprite, John," I was creating a new sprite. And I carried on creating new sprites and carried on creating new sprites. And then I was playing the game for about 10 minutes and I thought, wow, this is getting a bit sluggish. And when I paused it and looked in the debugger, I'd created over 400 sprites. And there was only like 3 on the screen. And I created like 400. So I thought, oh, that's not going to work, is it? No, it's not going to work. So we're going to have to do something slightly different. And basically what we're going to do is we're going to create a pool of sprites. And so when the one sprite finishes, we're going to mark it as that it's finished and it's no longer in use. And then when we need a new sprite, we go search in our pool, find the ones that are not being used and reactivate them. And so the way I'm doing that is by this. So after the player sprite, I am doing this. So before the ninja, and let me just get rid of this lot because we don't need it now. Access. That's it. So what I'm doing is I'm creating 10 small rock sprites, 5 big rock sprites, 15 axes and 15 fireball sprites, because at the very most we'll have 4 or 5 on the screen. And the ability of doing that means that when the sprite is off the screen, we can then reuse that sprite for something else. Alright, and so as we are using those sprites, we can reuse them. So the way we do that is if I go into the rock sprite now, we need to change the code in the rock sprite. So, and the way we do this is in the update, we test for whether we're off the screen. Yeah. So at the moment we test for the position, and then we say that it's active is equal false. So that means it's no longer being used. And then we've got this thing called Reactivate Sprite. And whoops, and what happens there is we're telling it we want you again, and so we're telling it where all the information that it needs to start again, and then it fires off. So in the game, then in our loop, so if we go back to the game, I can't see it on my screen again. Game, there it is. In our update, so if I scroll down to the update, here we go. You know, this update bit now here, we're going to put a lot more in there. Yeah. And what we're going to do is we're going to put this command in. And this is basically saying activate the sprites. Yeah. Now the code for this is in its own little routine that I've done to try and simplify it. So here we go. I don't think it's there. No. And what it's doing, it's saying for all the enemies in our list. So this is the list of enemies that we downloaded from the JSON file. We are going to update them all. So basically it ticks, gives them a tick, and then we're saying, does the current enemy say it needs a new sprite? If it does, first we tell it off, turn it off, and then we test whether it's a rock, a fireball or an axe. And if it's a rock, we then search through our pool of rock sprites, and if we find a rock that's inactive and it's the same size, then we tell that rock to reactivate, and here's the details of what I want you to do. And we do that with the fireball and the axe, and this allows us to reuse the sprite again and again and again and again. So at the very most we'll have 30 sprites, I think it works out to 30 sprites at any one time. Now, when I did it before, I said I had 400 sprites. It was ridiculous. But this way we only have 30 at the most, I think. Well, 15, 10, 5, 35. And this means that we're not taking any more data up, because these sprites have already been created when it starts. We then use them, and when they've finished off, when they've worked their way off the screen, then we disable them. And then when we need another sprite, we look in the pool and say, right, which one, who's first, who's not being used, who's not working, who's first. Right, we're using you, and then we reconfigure it. And that's what we do. Now, I've done an awful lot more since the last meeting, because the last video, because I've done scrolling and stuff like that. And what I was trying to do is trying to show you the concept of doing it. Now, for where is it main? We send in map 01. Now we're not going to be doing that. We're just going to be sending in 01, and this time it's going to be next chapter. We still have to do g.new, because we're still needing to do some new things in the system. Now I've got to see if everything's all set up. See, I'm not too sure if this is going to work, because I think I've missed some stuff. Let's try it. Let's go into debug. Let's find out what happened there. No such file, 01txt. Ah, that's because we're not using the new file stuff. Because we're doing self.chapter and it's not. Where should be yeah. Right, so what we're doing, where are we, what are we doing? Right, self.chapter, and then we load the map data, which is leveling.mapdata. That's that there. So why did it error? Let's see what's going on. This is loading the map. So he's trying to load 01. Load map. So it's doing it before our breakpoint. There it is. shouldn't be doing that now. Yeah, it shouldn't be doing that now. That is redundant code. Ooh, what's it failing on now? So it didn't load anything in. Map 01. Put a breakpoint on it. If this doesn't work because I'm trying to be ahead, I'm just going to load what I've got. And then I'll explain it. Right, let's go in there. Step over, go in. So, read. So we get the data. Yeah, it's got the data okay. Split it. And then we put it in self.mapData. Okay, so what's wrong with that then? Ah. That's why. Yeah, we know about you. Continue. There we go. So hopefully we should see, there's the boulder. Now, just to prove that it works, let's load the JSON file in. So on map 1 it's saying at level 260, delay for 3 seconds and then spit one out every 3 seconds. And do them at speed 5. So what we're going to do is we're going to slow it down to 10 just to show you that it works. Yeah, so go on to that, go into debug, run. So now we should have a lot slower oh, better take that breakpoint out, a lot slower boulder coming across the screen. So it's up here somewhere. Here we go. So there's us. Whoa! It's supposed to be slower. Why is that quicker? Did I do it wrong? Oh, speed 10. I speeded it up. Oh. Speed 2. This should be a lot slower. Right. Are we still running? Oh, that's because I'm on the JSON file. There we go. Come on. Here we go. So you saw how fast that boulder went last time. Look how slow it's going now. And because the frequency is 3 seconds, hang on, let me get the Raspberry Pi remote because VNC is having a bit of a keyboard. Right, here we go. So this is the keyboard for the Raspberry Pi. Here we go. No more jerkiness now. And because they're so slow, 3 seconds is this distance apart. Yeah. So let's say we wanted to add another boulder just for fun's sake. Let's add another boulder. So we'll copy that line, put a comma there, and what we'll do is we'll make it come above a head. So we're going to reduce the height, and we're going to say delay it for 1 second, Make it repeat every 4, but we'll have a lot higher speed, so we'll go 5, and we'll make it come in from the left, so it's crossing over. Yeah, now watch what happens. So I'm on the Raspberry Pi keyboard now. There you go. Can you see it? Goes straight across the top. Look at that. And I've got one coming across the bottom. So now we have got a way of defining what's going to happen with the levels. So just for the sake of argument, let's say you want a fireball. So we have to do this because we have to tell it it's a fireball in the enemies list. Yeah. Oops. Undo. Undo. Better. So that's that. So we put a comma there, and we then put the next sort of fireballs in. So we're saying fireballs at 2. Let's do in between the two. 230. Delays for 3 seconds. Frequency delay seconds, and we'll make them come in from the right. So run that. So now we've added a fireball. So I'm back on the keyboard for the Raspberry Pi. So there's our thing at the top, and there's our fireball coming in from the right hand side. And we should get another one in a minute. There it is. So now we can now define with those enemies that we've got, which is an axe, fireball, boulder, big and small. We can now define what happens on every level of Hunchback. So the first level will probably have one boulder that you have to jump across. Second level could have 2 boulders going in opposite directions, so you've got to be a bit more on your feet, and so on. Now what I'm going to do is in the next video I'm going to bring you up to date with what I've got, because it's getting a bit difficult trying to keep this code separate. So in the next video I'll bring you up to date, because I've added staging, I've started adding lives and collision detection and all that, and so we'll go through all that as well. And so 34 minutes, that's not bad going for me. So we've successfully developed a leveling system for this game, so we can now have as many levels as we want, but we don't have to code it. We just have to put it into that configuration JSON file that we've created, and this allows us the flexibility to try different things out without having to change the code, because all we do is just change the data in that file. Well, I hope this has been informative. If you're not too sure what JSON is, just give us a ping on Discord, and I'll try and explain it a bit more. I'm hoping you guys are following on, because I'm enjoying this. I'm loving this PyGame thing. So if you like what I do, hit that like button. If you don't like what I do, fine, hit the dislike button. Always leave me a comment, because I try and answer them all. And if you would like to support the channel, then consider becoming a patron of mine. All the money raised in the channel goes back to the channel. And with that, I'll see you in the next video. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.